These are the quiz corrections for quiz number 15, taken on April 12, 2016. Number 1 says factor completely. I'm going to identify my A, B, and C. A value is 1, B is -2, C is -15. Then you're going to use your X in your box. If you've actually been paying attention, when you have an A value that's 1, you actually don't need to do the box. So on the top you have A times C, which is -15. And then your B value is -2. So the two numbers that multiply to be -15 are 5 and 3. One has to be negative, so that's -5. And you add those together, you'll get -2. Just to practice the box, because if you do have a problem where it's A is greater than 1, you'll just take this here, -5, and you add an X there. It goes in the bottom left. 3 goes in the top right. Your first term goes in the top left. And in the bottom right goes your C value. Now, I want to show you guys a strategy. This is actually Monday's lesson of how to check your answer when you're actually doing the box. Okay? The opposite of factoring is just distributing or multiplying, so you can just multiply. X times X gives you X squared. X times 3 gives you 3X. X times -5 gives you -5X. And -5 times 3 gives you -15. My two binomials are X plus 3 and X minus 5, choice B. Question number 2, I'm going to look at the problem and recognize I have a 2 here, a -3, and a -12. I recognize those numbers do not have anything in common, so there's no GCF. So students are asking, when do you do the GCF? You should actually be looking for the GCF right away. What it does is it makes your numbers smaller. A value is 2, B is -3, C is -12. Multiply A times C is -24, and your B value is -3. I listed out all the factors of 24. And I'm trying to find values in which I can either add or subtract to be 3. So that would be 23, that would be 10, that would be a 5, and this would be a 2. Which means there's no two numbers which you can multiply to be -24 and add to be -3. That's called not factorable. We call that prime factor. For example, 1 times 11. 11 is a prime number. Question number 3. The only difference between questions 1 and 2 and 3 is 3 says solve. So when it means solve, it just means that you have to factor first, right, using your X box, and then you use the zero product rule. Before I do that, you'll notice that you have to set it equal to 0. A is 1, B is 13, C is positive 40. You'll get positive 40 here. Positive 40 because you need to add it to the left side. You need to set it equal to 0. So one strategy in solving quadratics by factoring is make sure it's set it equal to 0. There is your A, B, and C. A times C is 40. Your B value is 13. The two numbers that you have are 5 and 8. You'll notice that your 5 and 8 go in there. So your factors are X plus 8, X plus 5. So let's just say you stopped there. Your answers are not positive 5 and not positive 8. So it's not C, it should be D. Set it zero product rule, set it equal to 0, and you get -5, -8. Your X-intercepts are -5, 0, and -8, 0. Choice D. Number 4, I just asked you to complete the table. You have y equals -x squared plus 4. I would say about every 2 students, of 2 students, every 1 out of 2, 50% of the students, 50% taking the quiz actually filled out the table incorrectly. And they filled it out incorrectly just based on the negative sign. When it says y equals -x squared plus 4, it just says take the opposite after you do the exponent. You know to do that because of orders of operation. So some of you may have thought, oh, Mr. Ing, can I put in a -3 here and then change the sign and then do the power of 2? That's incorrect. This minus sign or opposite sign is like -1 times an x squared. So I'll go ahead and do one of these. You put in a -3. -3 squared is 9. Opposite sign of 9 is -9. -9 plus 4 is -5. The grading for that table, if you didn't get a chance, copy down that table of values. -5, 0, 3, 4, 3, 0, -5. If you identify the vertex at 0, you actually would have identified the symmetrical points. Do you see it? 0, 0, -5, -5. Some of you guys did not catch that. Just for question number 4A, to grade it out of 4 points, there's my rubric. You get 4 points if you had all 7 of those values highlighted in yellow and 0 wrong. I give you 3 points if you had 6, 5, or 4 correct, which means 1, 2, or 3 of them were incorrect. 2 points, there it is. Okay, so now some of you who had incorrect table of values, the most common thing, if you got them all correct, that's what it looks like. The other half of students got 0, 4, then all the other numbers are, I think, are like -13 and something else, right? And then you might have said, Mr. Ng, I got the same first differences and the same second differences, okay? But because these values were incorrect, you're getting these numbers from an incorrect source. Okay. For example, if Kobe Bryant last night made the 3-pointer outside of the court, yes, he did make a 3-pointer, but it doesn't count as 3 points. He's out of bounds. It goes against the rules. So for question number 4, I give you 2 points for completing the first and second differences. Remember, it's the values going down. So -5 to 0, you have to add 5. 0 to 3, you adding 3. Here, from go to 4 to 1, you are subtracting 1. And then after you complete the first differences, which means it's not linear, right? It means it's quadratic. It's quadratic because you have a second common difference. 5 to 3 means you have to subtract 2. All my second differences are -2. There was my scoring rubric. 2 points if you got your first and second differences correct. I give you 1 point added to your 1 pointer for trying if you just wrote yes, and then 2 points for an explanation. Something I wasn't looking for here is 2 to the power of 2 if it's quadratic, because it says does the table, not the function or equation itself, does the table, this, represent a quadratic? Okay. Backside. You should start recognizing what type of forms they are. So this one is in standard form. It's in standard form because you can identify an A, B, and C. A value is 1, B is 4, C is -45. When it's in standard form, you're going to use the equation x equals -b over 2a. That's a formula you're going to have to memorize. Your B value is 4. Your A value is 1, so this is 4 divided by 2, which is 2, and then you take the opposite of that, which is -2. X equals -2 represents your axis of symmetry there, which means that your vertex is going to be on there. To find the vertex, I'm going to take -2 and put it back into the function for every x value. This is -2 squared, which is a +4. That gives you -8 and -45. 4 minus 8 is -4. -4 minus 45 is -49. -2, -49 is your vertex. That should actually have been one of your versions, A or B, from the last quiz. So I've graphed my vertex there. I know it's graphing up because my A value is 1. And so sketch the label with your information, which we did. And don't forget the Y-intercept, which is your C value, -45. If you tried it and got nothing right, I gave you 1 point. If you got knowing that it parabola opens up, give you another point. If you labeled the vertex, give you another point. If you labeled the y-intercept, give you another point. And label the axis of symmetry, that dotted line where x equals -2, you got another point. It's going too fast, watch the video tonight. I got 6 minutes. For question number 6, says use the following h of x. Don't be scared with this. This is just function notation. If you're scared, you can just change that to a y value. So I have x plus 3 and x minus 5. These are in parentheses, so that means they're binomials, or we call that factored form or intercept form. To find the vertex, or I'm sorry, the axis of symmetry in intercept form, you need to find the X-intercepts. So what I'm going to do is already in factored form. I'm just going to set these equal to 0 by 0 product rule, and then solve for x. X is -3 and y is +5. So remember, that's just the midpoint. -3 plus 5 gives you 2. 2 divided by 2 is 1. So x equals 1 is your axis of symmetry. So we're just finding the midpoint, or p plus q divided by 2. You're going to take x equals 1, and then you're going to put it back into the function like you did in standard form. So put a 1 there, put a 1 there. And when you do that, you get negative 16. 1 comma negative 16 is your minimum, because your a value is also a positive 1 up here. So I know that it opens up. My axis of symmetry is 1. You can now graph negative 3 and 5 because you got that from your zeros. So the students who had the printed out version, I added a question where it says what are the zeros. A lot of students are writing negative 3 and 5. I want you guys to know that the zeros represent the x-intercepts, so this should be an ordered pair. So if you wrote negative 3 comma 5 for 6D, I only gave you 3 points. I want to go over interval notation for domain. Domain means going left to right. And as I move the cursor, the first thing I touch on the graph is the arrow. Arrows always mean infinity. Well, in this case, it's coming from the left side, so that's negative infinity. And as you move towards the right, the last thing you touch is another arrow, so that's positive infinity. Some of you guys will recognize, since we're doing all parabolas, your answer always, always, always for an interval notation is negative infinity to positive infinity, and then you always write all real numbers. To get the range, I'm going to go from the bottom to the top. Here I don't have like a line, so I'm just drawing with my mouse arrow. And the first thing I'm going to touch here is negative 16. It's negative 16 because I'm going on the y-axis. So that's negative 16. This is positive 1. So that's the first thing I'm touching, negative 16. As I go up, if I was able to drag a line, you would recognize that the last thing you touch are these arrows, which is going in the direction of positive infinity. So that's how I got negative 16 bracket, that means include it, comma, positive infinity. To get the range and inequalities here, you'll notice that the parabola is starting at negative 16 and then, whoa. That's correct, okay. I'm starting at negative 16 and the arrows or the parabola is going towards all the positive numbers, negative 12, 0, 6, 25, 500. So that means I need y values that are greater than or equals to negative 16. In this box, I gave you 1 point for every correct response, and this is how I graded your graph. Alright. Use the following. This is vertex form. The common mistake was to think their h is a positive 3. Remember, you need a minus sign in the problem, so it's h is negative 3. And your k is negative 1. Remember, your h and your k represent the vertex. So you could just take this and put it in there, negative 3, negative 1. You don't actually have to do any substitutions. Once you graph it, negative 3, negative 1. A value here is negative, so it's opening down, and your axis is symmetry. This graph was pretty simple. You don't have to find the y-intercept because it doesn't tell you to. A simple way that I graded the problem is that you knew that it opened down, axis of symmetry at negative 3, and the vertex negative 3, negative 1. Alright, I want to talk about increasing and decreasing for 7E. Let's see, I can't get there. There it is. Increasing and decreasing refer going from left to right. So it's like if I had to drag a line here, the first thing you're going to touch is this arrow and you're going to stop at negative 3. So this portion is increasing. Well, you're coming from negative infinity, right? And you're stopping at negative 3. Now that point, negative 3, on the x-axis as you're going towards the right, this is now decreasing. It's going down. That's how you know it's decreasing, going down. If I drag the vertical line, you'll notice I'm starting at negative 3 going towards that arrow. That's positive infinity. Here's another hint to make sure you're doing it correctly for increasing and decreasing. There are no brackets. There are no brackets. For this class, you were not graded on nor penalized for finding the zeros, x-intercepts. If you did, gave you extra credit. It's an algebra 2 problem. The answer is x equals negative 3 plus or minus I. I hope this was helpful for your test tomorrow.